This is CPM Precalculus Chapter 1, number 74. So here we're given a triangle. It's a right triangle, and we're asked to solve it. So this is triangle PQR, and we're asked to solve it. We know solving it means know all three angles and all three side lengths. Right? All three angle measurements, you could say. All right, let me cross out the S, measurements, and all three side lengths. Okay? So PQR. Here's P, Q, I'm just making it bigger, and R. So we're given a few things about this triangle. We know this angle is a right angle, right? So we know the measure of angle Q is equal to 90 degrees. We know the side here is 8. Oops. We know, I cannot trace very well. This side is 8, so the side QR is equal to 8 centimeters, right? And we know side PR. We know side PR is equal to 16 centimeters. And we just need to find this side, this angle P, and this angle R, right? So we need to find this side, this angle, and then we will have solved the triangle. So let's start off by looking at what information do we have? Well, we have two sides and one angle, and we know, given a right triangle, we know we can use the Pythagorean Theorem, which is c squared equals a squared plus b squared, and we can use trigonometric functions, which is our sine, cosine, tangent, and our little memory tool, SOHCAHTOA. Okay? So, let's start off by looking at Pythagorean Theorem. Because we have two sides, right? We know this side is 16 and this side's 8. We just need the third side. So which one is A, which one's B, which side is C? Remember, C is always opposite the right angle, always the longest. So C is 16 squared. And A and B are just the other legs of the right triangle. So they're not the hypotenuse. So if A is 8, then we'll just call this, instead of question mark, we'll call this B plus B squared. Okay? Then we can use our calculator. 16 squared is 256. 8 squared is 64. And we still have B squared. Subtract 64 from both sides. 256 minus 64 is 192. Okay, so we get B squared equals 192. And now we can reduce this. First, we want to get B alone. We square root both sides, right? So we get B is equal to plus or minus square root of 192. Okay, plus or minus because it can be positive or negative, and we're going to square it, so it's going to become positive ultimately. So, but at the same time, we know B cannot be negative because it's a real, actual side of a triangle, and side lengths cannot be negative. So we know B has to be positive square root of 192, right? And we could just write that as square root of 192. Okay. Now, 192, we can simplify this square root. So to simplify the square root, I know that we could divide it by 64, but if you didn't know that, well, what are the factors of 192? So 192, if we divide it by 2, we get 96. So 2 times 96. If we divide 96 by 2, we get 48. So that's 2 times 48. 48 divided by 2, we get 24. 2 times 24. 24 divided by 2, we get 12. Well, we can keep going for a while. 12 divided by 2 is going to be 6. 6, can we divide it by 2? Yes, it's going to be 3. So how many 2's do we have? 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2 times 2 times 3 is equal to 192. So that's 2 to the power of 1, 2, 3, 4, 5, 6 times 3 square root. Okay, I'm just simplifying this because we know that's the same as 2 to the 6. We know that's 2 to the 3 times 2 to the 3. We could have started that way if we wanted. Ultimately, once we get two of the same things inside the square root, we could take them both out and make them 1 outside of the square root, right? So these two are the same, so we pull them out of the square root, and it becomes 2 to the power of 3, which is 2 times 2 times 2, or 8 square root of 3. Okay? So let's go back, because now we have, let me go back up here, we have b, let me write in blue, is equal to, what do we say, 8 square root of 3. B is equal to, or let's not call it B, well, I could call it B equals side PQ, and that's equal to 8 square root of 3 centimeters. I guess we could have just plugged in the square root of 192 in our calculator, and we could say, or approximately 13.856400646. Rounding it to 3 decimal places is 856 centimeters. Okay? So now we have all three sides, right? This is no longer a question mark. We have all three sides. And now we just need to get all three angle measurements. Okay. So let's move to the right. And let's copy this triangle over here so we can see it. And we know, okay, so now we have the triangle here. We know this is 8 square root of 3 centimeters, and this is the right angle. We just need to know this angle, and then we'll be done. So how do we do that? Well, we have to use our trigonometric functions, right? Those are our SOHCAHTOA, so sine, cosine, tangent. So let's first look at this angle right here, angle P. Angle P. So let's solve that. So we know sine of angle P, right? Sine of angle P is equal to the opposite side, O over H. The opposite side is 8. The hypotenuse is 16, right? So we know sine of angle P is 8 over 16, or 1/2, right? 8 divided by 16 is 0.5, or 1/2, or 0.5, okay? Now, once we have sine of our angle is equal to 0.5, what do we do next? Well, remember when we look at inverse functions, we know that the inverse function of sine is written like this. If we do that to both sides, by doing that, what I mean is if we say the inverse sine of our left side, we can say that's equal to the inverse sine of our right side. Okay, so we just added inverse sine on the left and right and kept our input as the left and right side. Oops. So when we do that, we can see that inverse sine and sine cancel each other out, because this is just like the wrap and the unwrap of the opposite, doing the opposite. So we're left with angle P is equal to the inverse sine, right, of 0.5. And that we can plug into our calculator. So inverse sine of 0.5, and I get is equal to, so let me check to make sure my mode is in degrees. So if I'm in degrees, I get 30. And if my mode is in radians, and I compute this, I get 0.5235. Oh, that 5 after the 3 makes it a 4 if I round it there. And let me say approximately 0.524 radians. Okay? So angle P, now let me write that over here. Angle P is equal to 30 degrees, or I could say 0.524 radians. Okay, so I found angle P. Now I need to find angle R. So to find angle R, I can use my trigonometric functions, right? And I can use angle R as a reference. So if I'm looking at angle R as a reference, and I can say sine of angle R is equal to, well, the opposite side of angle R is 8 square root of 3 divided by the hypotenuse of this triangle is 16, right? And then I do exactly what I did above. I take the inverse sine onto both sides, and I get the angle measurement. Okay. Another way I could solve for angle R is to remember that if I add up all three angles in a triangle, that's angle R plus angle P plus angle Q, the measurements of each angle, they add up to be 180 degrees. This is always true no matter if it's a right triangle or an obtuse triangle or an acute triangle, it's always true. So angle R, we don't know, but we know angle P, we just solved, it's 30 degrees. And we know angle Q is given to us as 90 degrees. So this we could use to solve for angle R, or this we could use to solve for angle R. This is much easier. I don't even need a calculator. I just combine like terms. 90 plus 30 is 120 degrees. Subtract 120 from both sides. And I'm left with angle R is equal to 60 degrees. Okay? If I did it this way, I would get exactly the same thing. Or I would get, let me do it really quickly. 180, 60 times. Or I would get 1.047 radians. Okay? So here in my solving the triangle, I have now angle R is equal to 60 degrees. Okay? So I solved for all three side lengths and all three angle measurements. And that means I solved this triangle. Oops, let me box everything a little better. Okay, so here's my angle Q, angle P, angle R, side QR, side PR, and side PQ. So I solved the triangle. So this ends CPM Precalculus Chapter 1, number 74.